Good day, everyone. I hope you are doing well and blessed this morning. All right, this is your tutor Bongani Masango. Today I'm going to be doing concentration. All right. Now, let's start. When we define concentration, we say it's a measure of the amount of solute that is dissolved in a given volume of a liquid. All right, they can also use the term here, solvent. All right, so a solute, it is what you are going to dissolve, and a solvent or a liquid is what you use to dissolve the solute. So, for example, let's say you have salt and water, and you're going to dissolve salt into water. Your salt is your solute, and your water is your solvent. All right, so the SI unit that we use for concentration is mole per cubic decimeter. All right, the formula we use is concentration is equal to number of moles over volume. Number of moles we know is in mole, and volume we know is in cubic decimeter. Okay, so the concentration is mole per cubic decimeter. All right, number of moles, mole, volume is in cubic decimeter. Or if you were to manipulate this equation, all right, you're going to see, okay, you're going to see that number of moles is given by mass over molar mole. Okay, therefore C was going to be mass over molar mass, sorry. All right, then we divide by V, which will be mass over molar mass. When we multiply, the V becomes reciprocal 1 over V. All right, and therefore when you times the two, mass times 1 is mass over molar mass times volume. All right, this is actually what you have here. Okay, so it's just showing you that part. But anyway, you are given the formula sheet. You can see the formulas there. All right, here where mass is represented by M in grams, the molar mass, capital M, is in grams per mole, and the volume is in cubic decimeter. Okay, and the concentration is in mole per cubic decimeter. Now remember, sometimes they can say give the concentration in mole per cubic centimeter. Therefore, if your volume is in cubic decimeter, you need to multiply it by 1,000 to convert it back to cubic centimeter. All right. Now, in the previous, I think, lesson, I did explain how to convert liters to milliliters and so forth. All right. Now, looking at another term that we use for concentration, or that you can find, is molarity. Okay, they can say calculate the molarity of a substance. All right, which also uses the same unit as concentration, because it's concentration, mole per cubic decimeter. Or sometimes you can use a capital M, which represent molarity. Okay, maybe your answer is 5, then it's 5 capital M, which is 5 molarity. But I would advise you to stick to mole per cubic decimeter always. All right, unless otherwise given from the instructions. Okay, the capital M is molar, as I've said. Now, what is a standard solution? Okay, if the question says prepare a standard solution, normally they prepare this solution before they can do any chemistry experiment. Okay, when it has to do with titration, you will learn about that in grade 11. Okay, so what is a standard solution? A standard solution is an accurately made up solution with known concentration. So the concentration must be known in order to prepare this standard solution. All right, so that's what we have for concentration. I just want us to look at some few examples that we are going to use. Okay, remember when we do this, you must always have your calculator. All right. Okay, there we go. I do believe that you can see now. Okay, if 3.5 grams of sodium hydroxide is dissolved in 2.5 cubic decimeter of water, what is the concentration of the solution in mole per cubic decimeter? Okay, here you are given the mass, all right, and the volume. Okay, you are given the mass and the volume, and you can get the molar mass. All right, so the best formula to use would be mass over molar mass multiplied by the volume. Okay, what is the mass? It is 3.5. What is the molar mass? Remember, this is 23 plus 16 plus 1. Okay, remember you still have a volume to multiply with, which is 2.5. It's in right SI unit, you don't have to convert it, and therefore you are going to get your answer there. Okay, so I hope you can still see 3.5. Remember guys, you need to know how to use your calculator. Well, I don't have to put brackets there, but anyway, I don't have to put brackets here. 3.5 over 23 plus 17. Well, you can see that's 40 already, and then multiply by 2.5, and then there we go, you get 0.035. Okay, so your concentration is 0.035. What is the SI unit for concentration? Is mole per cubic decimeter. Please also take note here, we use a capital C, guys, for concentration. All right, not a small letter c, because the small letter c represents centi. Okay, so you must use the correct symbols and the correct SI unit. Okay, alternatively, let me give you another option. Someone can say, I'm going to look for the number of moles of sodium hydroxide, which is mass over molar mass, and therefore the mass is 3.5, and the molar mass of sodium hydroxide, we said it's 40. And then they get this answer, 3.5 over 40, and then they get SD 0.0875, 0.0875 mole, all right, and therefore C equals to number of moles over volume, therefore is 0.0875 over the volume that was given, which is 2.5, and then it divided by 2.5. Okay, the answer is 0.035 mole per cubic decimeter. See, it is the same answer, but now this is a long route, so rather used what is given to you, which was a mass there and the volume, and you can get the molar mass. You see, in 3 steps you can get this. When they mark this, okay, they can give you a mark for the formula, a mark for putting the mass, all right, and the mark for correct multiplication here, 2.5, which is the volume and the molar mass, and the mark for the answer. So roughly 4 marks, okay, 4 marks when you are doing this question. But anyway, so the next question says, how much sodium chloride in grams will one need to prepare 500 cubic centimeter of solution with a concentration of 0.01 mole per cubic decimeter? You see, this concentration is known, so it's our standard solution. But anyway, how much sodium chloride in grams? Remember, guys, you are not always going to be asked directly calculate the concentration. Sometimes they will say calculate the molar mass, calculate the volume, calculate the mass, depending on the type of question given to you. Now, let's calculate the mass now. We are given the concentration. Now, please take note. The concentration is in mole per cubic decimeter. You can see. Yes, and the volume given is in cubic centimeter. These two units are not the same. You need to convert this to that. So you are going to convert cubic centimeter to cubic decimeter, which you divide by 1,000. All right. So the volume will be 500 divided by 1,000. All right. We know that is going to be 0.5 cubic decimeter. Okay. But anyway, C is equal to mass. Okay, they are looking for mass. This is the best equation to use because it has a mass over molar mass multiplied by the volume. What is the mass? Okay, let me just stop here. What is the concentration given? It's 0.01, which is the mass that we are looking for. All right, and what's the molar mass? What is it? It's sodium chloride, guys. So sodium chloride is written like this, NaCl. Okay. And so it's going to be 23 plus 35.5. Okay. Multiplied by the volume. Are we given the volume? Yes, we converted 0.5. Okay, so half of this. Okay. And you use your calculator. Okay. This is going to be 58.5. Yes, 58.5, and then half of it is 29.25. Then you multiply that. What answer you get here, you cross multiply. So it's going to be m times 1, which is m, and then whatever you got here, multiply by 0.01, and your answer is going to be 0.29 grams. Okay, I hope you got that correct. You got it right. I believe so. Okay, I want to give you something to do. Okay, these are practice questions. You can try these out. Okay, and then just pause this video and try them out. And yeah. Okay, now let me continue. Let's see what you got. Remember, you must practice in order for you to get used to this thing. Otherwise, you are not going to win during an exam. Okay, practice questions. Now, 5.95 grams of potassium bromide. You must know how to name the compounds. My first two videos are teaching you how to form a compound and how to name it as well. So 5.95 grams of potassium bromide was dissolved in 400 cubic centimeter. You can see it's in cubic centimeter. When you convert that, you divide by 1,000 to take it to cubic decimeter of water. Calculate its concentration. All right, so it's C is equal to mass over molar mass times volume, because the data that is given here suits this formula very well. Okay, then what is the mass? It's 5.95 over, okay, over what is the molar mass? This is potassium bromide, so it's KBr. Okay, well, I didn't see this coming, but what is the molar mass for bromide. I know potassium is roughly 30 something. Well, 30 something. Okay. Okay. I find that the potassium is going to be 39.1. Okay. Man, I forgot to add here. Okay, it must be plus here, sorry. Plus bromide, which is 79.9. Okay, multiply by the volume, which is 0.4. Do you agree? Because we're going to divide 400 by 1,000. Okay, so that's what we have there. And then let's use our calculator. It's going to be 5.95 over 39.1 plus 79.9 multiplied by 0.4. Or you can put 400 over 1,000 here, right? But if you know, then you know. Okay, so the answer is 0.125 mole per cubic decimeter. Okay, I hope you got that correct. All right, let's move on to another question. What is the molarity of the solution formed by dissolving 80 grams of sodium hydroxide? We are given sodium hydroxide in 500 cubic centimeter. You see, you must convert that to cubic decimeter, unless otherwise they want it in this form. Okay, but the SI unit needs it to be converted, okay, of water. Now the question is asking for molarity. What did we say about molarity? It is what? The concentration, okay, in mole per cubic decimeter. So we are looking for the concentration, okay, a mass. We have the mass over molar mass multiplied by the volume. Okay, what is the mass? It's 80 grams. Remember, if they try and trick you and put milligrams, a centigram, microgram, nanogram, you need to know how to convert to grams. We are looking for grams, not any of those prefixes. All right, and then what's the molar mass of sodium hydroxide? We said it's 23 plus 16 plus 1, so it's 40 multiplied by, what is our volume? 0.5. Remember, you need to convert that. Okay. Okay, let's do this together again. It's going to be 80. I hope you can see. Over, it's actually 20. Half of 40 is 20. Okay, so it's 80 over 20 actually. Okay, and the answer is 4. All right, so that is 4 mole per cubic decimeter. Okay, now if they normally ask you to 2 decimal places, okay, this is the same, guys, as 4.00 mole per cubic decimeter. It's the same thing, okay, because it's only 4. There are no numbers following there. So now this is going to be your answer. All right, I don't want you to write it as 4 molar. Please leave it like that. Okay, I hope you got this. Thank you so much for watching, and don't forget, guys, subscribe, share. Thank you so much. Have a blessed morning, have a blessed day, and see you once again when I return.